In this video, we're going to learn how to write a logarithmic expression as a single logarithm. In the top left corner, I put those 6 important logarithmic properties that we're going to use for the duration of this lesson. So we're going to start with this example, which we're going to write the expression as a single logarithm. So we see we have 2 logarithms. Right now they do have the same base, but they can't be combined with that first property until I take care of that 4 that's in front of the log base a of 3. So using the last property, I'll move that number into the logarithm as the power for 3. So I'll have log base a of 7 plus log base a of 3 to the 4th. 3 to the 4th is 81, so I'll have log base a of 7 plus log base a of 81. And then, now that I have both the logs without the coefficients, I can use that first property to combine them into 1 by multiplying 7 times 81. So I'll get log base a of 7 times 81, which is equal to log base a of 567. The way you can do that math quickly is do 7 times 80, which is 560, plus 7 times 1, which is 7. Now here I have 2/3 natural log of 8 minus the natural log of 5 squared minus 1. So again, I have 2 natural logs, but I do have a coefficient in front of that first one, so I'll move it to the inside. So I'll have natural log of 8 to the 2/3 minus natural log of 5 squared minus 1, which is 25 minus 1. And before I can combine these, I would just subtract those two. So it can be simplified, and I would raise 8 to the 2/3 power. Now, if you've forgotten how to take care of rational exponents, 8 to the 2/3 power is also known as the cube root of 8, then raised to the second. The cube root of 8 being 2, and 2 squared being 4, makes this 8 to the 2/3 equal to 4. So I can write this as natural log of 4 minus the natural log of 24. And since I'm subtracting these two logs, I can use that middle property to get the natural log of 4 over 24, which simplifies to be the natural log of 1/6. Now normally I would just stop here since I got that single logarithm, but I do see a property I can use since the numerator is 1. I can rewrite this, I can expand it for a second, even though it goes against what the problem's asking for, by using that division property to get the natural log of 1 minus the natural log of 6. And the reason why I'm doing this is the natural log of 1, whenever 1's within a logarithm, that's equal to 0. So I actually have 0 minus the natural log of 6, giving me negative natural log of 6 for the answer, which I think is a more elegant answer than natural log of 1/6. Then in the top left, I have 4 logarithms that can start to be combined. So first, I'll combine these first two. They're being added, so that can be rewritten as log base a of 9x. And the other two, I'll do plus, but when these get combined, you'll get log base a of x squared plus 1 divided by 5. So I combine those two together and these two together, and now I'll combine these two together, giving me log base a of 9x times x squared plus 1 over 5, which can be combined together into one expression to be log base a of 9x times x squared plus 1 all over 5. So if this looks like too many terms, you can combine into one logarithm, which will be a technique we'll use later for equation solving. Now for this next example, I have log of x squared plus 3x plus 2 minus 2 log of x plus 1. This is the common log, that's why you don't see a base. But before I can combine those two with the subtraction property, the quotient 1, I need to move that 2 into the logarithm. So I'll have log of x squared plus 3x plus 2 minus log of x plus 1 squared And now that I've gotten rid of the 2 and moved it into the log, I can now combine these with the quotient property to be log of x squared plus 3x plus 2 over x plus 1 squared. And I do have a rational function, and I could try to put it in lowest terms to simplify the look of it. So I can factor my numerator to be log of x plus 1 times x plus 2 over x plus 1 squared. And you'll see here that one of the x plus 1's can cancel, leaving me with log of x plus 2 over x plus 1, which is a much simpler looking expression than what I had before. That's my one logarithm. Now here, I have a few things to unpack. I'm first going to rewrite that square root as to the 1/2 power to help with this next part. 3x minus 2 to the 1/2. Then I have minus log base 2 of 4 over x plus log base 2 of 4. Now when the 8 goes into the log, so I can start combining these, it'll become log base 2 of 3x minus 2 to the 1/2 times 8. So the powers actually multiply together when it enters the expression. So 1/2 times 8 is 4. So that gives me log base 2 of 3x minus 2 to the 4th, then minus log base 2 of 4 over x, and then plus log base 2 of 4. Now when I combine these first two, when I subtract and divide by 4 over x, when I divide by 4 over x, it's the same as multiplying by its reciprocal. So a technique I can use is I have log base 2 of 3x minus 2 to the 4th times x over 4. And since I'm adding that last one, I can also multiply by 4, since they all have the common base. So the minuses I divided by, while the ones I was adding just stayed in the numerator. And that division caused me to use the reciprocal. And then you can see here that the 4's can cancel, leaving me with my answer of log base 2 of, I'll move this x to the front, x times 3x minus 2 to the 4th. And lastly, I'm going to use that same technique I just used up here. I have two common logs with rational functions in them. When I combine them into one, I'll get log of x squared plus 2x minus 3 over x squared minus 4 times the reciprocal of this, since I'm dividing by it. So that'll be x plus 2 over x squared plus 7x plus 6. And to simplify, very similar to the example I did on the left, I'm going to factor all of my quadratics to give me log of x plus 3 times x minus 1 over x plus 2 times x minus 2 times x plus 2 over x plus 6 times x plus 1. And we'll see which factors can cancel out. I see here the x plus 2's can cancel, but I don't see any other factors that can cancel, because that's x minus 1 and that's x plus 1. So now I'll combine this into one big rational function to be log of my numerator, x plus 3 times x minus 1. And then in my denominator, x minus 2 times x plus 6 times x plus 1. And that is how you write a logarithmic expression as a single logarithm.